in some cases, you need to use the graphical solution to be able to find some velocity or acceleration problems. Let's learn together how to build a graphical representation of velocity and acceleration, and how to find the velocity and the time for a certain question based on a given graph of that velocity or acceleration. So here, first we will learn how is the graph constructed. We have a golf ball that we discussed before. It's going from 0 meters to 5 meters at a certain time stamps. It's going from 0, 1 second, 2 seconds, 3, and 5 seconds, and so on. Now, what we do, the first step we take from the graph, we will build a table. And that table is representing, in this case, if we're talking about velocity, it is time and position. Then you will be able to draw that in a graph on the XY direction. So here we built, based on that graphical illustration, a table that is representing the time versus the position of the ball. At 0, it was at 0 meters. At 2 seconds, the ball was at 2 meters. At 5 seconds, the ball was at 5 meters. Now we take the values of time and the position in XY representation. We can choose to have the time on the x-axis and we have the position on the y-axis. So we can go at 0, the position was 0. So I will draw a point 0 and 0. At time 1 second, the position was 1. So I'll go 1 second, the position was 1. I will draw another point here. At 2 seconds, the position of the ball was at 2 meters. At 3 seconds, it was at 3 meters. At 4 seconds, at 4 meters. At 5 seconds, 5 meters. We can see we are drawing a kind of linear line from the initial point to the final point. Then you can draw your line, and that represents the velocity of your ball. In this case, it is a linear line going from point 0 and 0 to point 5 and 5. So that's how graph is constructed, but in many cases the question would give you a graph and ask you to draw out some of the parameters, like either the velocity or finding the position at a certain point or finding time at a certain position and so on. So now we know how the graph is constructed. Let's try to understand the velocity graphs. So velocity usually is a time versus position representation. Why is that? Because if you remember the equation of velocity, it is distance over time, or it could be the change in x position over the change in time. Could be change in s over the change of time. Whatever the representation is, velocity is distance over time, or change in distance over change in time. So it makes sense the graph would be representation between the time on the x-axis and position on the y-axis, or vice versa. Now, to find the velocity, you need to use the equation of the slope. So the velocity at each point is different. So we know that from a previous explanation that the slope is the rise over the run, and the slope in this case represents the change in position over the change in time. So if we go here, that's the base of the triangle. So here you are talking about the slope at this point. The slope would be the change in position, position 2 and position 3, over the change in time at 2 seconds and 3 seconds and so on. We can, in a simpler forms, related to the velocity, say slope equals the change in distance over the change in time, or delta x over delta t, and that would be x final minus x initial over t final minus t initial. And this case, if we want to find the velocity of the whole graph, so we will keep in mind we go from 0 to 5 seconds, and we moved from 0 to 5 meters in position. So to find the velocity based on this graph, like the total velocity, would be delta x over delta t. And that would give you x final minus x initial over t final minus t initial. What is x final, or the final position was 5 meters, minus initial position was 0, over final timing was 5, minus initial timing was 0. That would give you 1 meters per second in velocity. So your velocity is 1 meters per second for the whole graph. Another type of velocity graph, what if the velocity is decreasing? That's how the graph would look like. So we have time on the x-axis and we have position on the y-axis. We start from point 0 and 5 over here. At time 0, the position of the ball, let's say, was 5. At time 1, it was 4. Time 2, it was 3. Time 3, it was 2 meters. At time 4, it was 1. At time 5, it was 0. So it's obvious that the velocity is decreasing in this case. To find the velocity of this graph, we can use the slope. The slope equals the change. In this case, slope equals velocity. And we know the slope in this case equals the change in distance over the change in time. What is the d final? That was 0. At the final location, what was the position? 5 seconds, but the position was 0. Minus, at the initial location, over here, we had 0 time, but the position was 5. So we can say 0 minus 5 over what is the final time? 5 seconds, minus initial time, 0 seconds. That would give you minus 1 meters per second. It means the velocity was decreasing 1 meters per second. In the same way we discussed about velocity, acceleration is able to be represented in graphs as well. So we start with a table, we represent the table in a graph, and that would be the acceleration graph. The graph x-axis would be represented by time, and the graph y-axis would be represented by velocity. We get the points where the time is 2 and velocity is 7, and put it on the graph, whereas the time is 3, velocity is 13 on the graph, time is 4, velocity is 16 on the graph, and if it's a straight line, then we connect the dots. It could be sometimes not straight line, then you want to represent it as needed. So you just follow the dots or the points that you put on the Cartesian, and that would be your acceleration representation graph. Now, what if we want to find the acceleration of this graph of velocity versus time? Acceleration, again, represented by the slope. The slope is rise over the run. So A equals the change in velocity over the change in time. Please differentiate between velocity and acceleration. In velocity, we used to look at similar graphs, but we have time versus position. Now we're looking in acceleration graph, time versus velocity. Slope in this case represents change in velocity over change in time. That would give you the acceleration. So following the acceleration equation, now v final in this case at 4 seconds was 15 meters per second minus v initial was 0 over t final was 4 minus 0. That would give you 15 over 4 meters per second squared. A little lengthy comprehensive example on how to draw the position time graph and velocity time graph and how to find acceleration. So the example is saying the position time data for an ATV, which is a kind of vehicle used for vehicle sports, approaching a river, are given in the table over here. So that's your table for position and time. Now, using these data from the table, first you need to draw position versus time graph, then you draw velocity versus time graph, and you calculate the acceleration. Now, for the part A of the question, position versus time graph, we will go to the time and position from the table. We will draw an XY graph, and we say x-axis represents the time, y-axis represents the position. As you can see here, time on the x-axis and position on the y-axis. At 0, 0, time is 0, position is 0. At time 1, position was 13.5 over here. At time 2, it was 24 meters. At time 3, it was 31.5 meters. At time 4, it was 36 meters. At time 5, it was 37.5 meters forward. Now you connect those dots and you can realize it's not a straight line. We have a curve over here, but that is satisfying the first part of the question, and we already drawn position versus time graph. Part B, he said draw a velocity time graph. Firstly, we need the velocity values per time, like at 0 seconds, 1 second, 2 seconds, 3 seconds, and 5 seconds. What was the velocity? I need to create a table before I draw a velocity time graph. That table includes time versus velocity, and you'll be able to draw those points on an XY axis. It's a little complicated here because your position time graph that you had first is nonlinear. So in this case, what you're gonna do, you need to find the slope of the tangent at 2 seconds, 3 seconds, and 5 seconds. If you are familiar with the mathematical term of a tangent, so if you go at 2 seconds and you draw a straight line in the 2 seconds point, and at the 3 seconds point, and at the 5 seconds point. So at 2 seconds, the straight line was intersecting with a certain value on the y-axis and certain value on the x-axis, and the same thing for the other side of the tangent. And you can use those using the velocity equation to find what is the velocity at that exact point. The slope in this case equals delta d over delta t. We found out that the first tangent is, the final tangent is projecting at 32.5 meters minus 15.5 meters. So 32.5 minus 15.5 over 3, the final time, minus 1 for the first time, and that would be 17 over 2, give you 8.5 meters per second. Again, we need to draw that at 2 seconds, 3 seconds, and 5. At 3 seconds, we follow the same approach as we see here. Then we found the velocity from the tangent at 3 seconds is 5.5 meters per second. And for the third one, we have the tangent is horizontal line, so the slope in this case is 0, so there is no velocity at that point. Now we built our table of velocity. At time 2, velocity 8.5 meters per second. At time 3, velocity 5.5 meters per second. At time 5, velocity was 0. If you draw that on an XY axis, time on the X, velocity on the Y. So at time 5, velocity was 0. At time 3, velocity was 5.5, and at time 2, velocity was 8.5, so that represents a straight line. So now we already drawn velocity versus time graph in this case, so we are good to go with the part B of the question. Now the third part, calculate the acceleration. Easily, since we already have the velocities and we have the timetable over here, we can easily find the acceleration by using this equation, change in velocity over change in time. Final velocity was 0, minus initial velocity was 8.5 in this case, over final time was 5, initial time was 0, that would give you minus 2.8 meters second squared. Why we say minus? Because if you look at the graph, the acceleration as moving in time, acceleration is decreasing, which we call deceleration in this case. So it makes sense to have a minus value for that acceleration.